Kia ora koutou, Reese from QuickSense here, and today we are looking at calculating fractions. In this question though, it's asking us to simplify, and it's simplifying one fraction added to another. Now we can only do this if the denominators are the same, right? We can't add things that are different, we have to make them the same, and in this instance it's the same fraction, the same size of fraction. So, what I'm looking for is called a lowest common multiple. Lowest common multiple, sometimes referred to as LCM. And you don't have to use the lowest common multiple, you can use any common multiple, but the lowest just makes it a little bit simpler and we don't have to simplify it later. So what I could just do is just 3 times 9, right? That'll give me a common multiple. But I recognize that actually 3 goes into 9 3 times, right? 3 times 3 is 9. And if I do it to the bottom, I have to do it to the top as well. So whatever this is, plus 9, 1/9, well that's 3 over 9 plus 1 over 9, simplifies to 3 plus 1 over 9, giving me 4/9. And that is 1/3 plus 1/9 as simply as possible. Now, this example here is giving us some variables, not known values, and we know that they're going to be different as well, which is going to be important because we are looking for which ones are not equivalent, right? So which ones are not equivalent? That is, they don't equal the same thing. Now, what we can see is that they're actually given as A, B over C, right? It's a mixed number, so it's got a whole number and a fraction. But what we're going to do is we're going to try and change them all to look like this here. Okay, so this is going to be an improper fraction. And that's just going to allow us to compare them. And what do I mean by that? Well, A over B, C, if I think about this using real numbers, and I don't know that these are the numbers, but I'm just going to use it as an example, 4.5, if I want to change this to from a mixed number to an improper fraction, well, I know that 4 is some number of halves. So how many halves go into 4? Well, it's 4 times 2. So it's going to be 8 halves in 4. And then plus 1 over 2, which gives me 8 plus 1 over 2, or 9 halves. And you see what I've done here is I've multiplied this term down here by this term here, right? And that's allowed me to see how many of that fraction am I adding in my improper fraction. So let's use the ones that we have at our disposal. So the first one, A, B over C, well that's going to equal C lots of A, we write like that because A comes before C in the alphabet, over C. So this is how many of the fraction that we have, plus B over C, AC plus B over C. So that's our first mixed number as an improper fraction. The second one, right, it's got a similar form, whole number fraction. So this is A lots of C over A plus B over A, AC plus B over A. The next one, B A over C, C lots of B, but B comes before C, so we're going to do it like that. And that equals BC plus A over C. And then our last one we just keep as it is, right? So we've got, just dividing them up here. Our last one is BC plus A. It's already in this form. Now we're going to look through and see which ones are equivalent because we want the ones that aren't. So down here, they're the same. right? So these two here equal each other. AC plus B over C is not the same as AC plus B over A because A, B, and C are three different integers. The only way this is true is if C equals A. We know that's not true, therefore A, B over C, and C, B over A are not equivalent fractions.